Hello explorers and welcome to another video. Today I'm going to talk a little bit about RabbitMQ, and MQ stands for message queue or a message broker. So this concept is that you have some kind of service that takes a bunch of messages for you, filters them, puts them in different queues, and you have then other services that picks these up and does some work on them. So you have some sort of producer that creates messages, sends them into the system, they are filtered, queued, and then you have a consumer that actually fetches the message and does some kind of work. So today I'm going to go through how to set up a simple RabbitMQ, and then how to send something into the network. We're gonna fetch that, do something, and then send it to another queue, and then retrieve it from that queue when we are done. So let's go into the coding. So switch over here to my little virtual box. So first off, we will look at some code. So this thing we have, we can take the receiver first. First off, we have a connection function. So this is how we connect to our RabbitMQ server. We will create a factory, a connection factory. We will set a host, we will set username and password, and on RabbitMQ, if you don't specify anything, the username and password will be guest. And then we will create a connection and create a channel to talk over. So in order to use this, we actually need to start the RabbitMQ service. And I have pulled down the RabbitMQ Docker containers. So you do Docker pull RabbitMQ, and then you will fetch the RabbitMQ Docker containers. And then when to run these, you run docker run as a daemon -d. We'll set the host name, and this is important that you actually set a host name, because that's the path that RabbitMQ will use to store your data under. So if you have a RabbitMQ with a specific host name, it will store your data under that directory in your Docker image. So we started with my rabbit as a name, then we will set a name for the container so we easily can find it. This is some rabbit, I guess. And then we do RabbitMQ, so that's the Docker containers name, and we will take the latest of those. So let's start that up. The name is already in use by a container, so let's docker start the some rabbit then. So that's what we actually did here, is that we ran it as if we didn't have this container, but I have done this before, so I already have this some rabbit, so I will just start that one, and then I can do a docker inspect on some rabbit, and the important part here is that you actually get the current IP address for this Docker instance, and that IP address is the IP address you want to use in your different applications when you send data to your Docker image. So it's important to know that. And when you set it up in a larger setting or use a Docker image that you deploy to some site, they are usually have some kind of console where you can find this information, what IP or what host name your RabbitMQ is hosted under. So that's an important part to fetch and keep in mind. And it seems that my IP address hasn't changed, so that's good. So this is my connect function. And if we go into my main function for the receiver, I have my channel here that I have connected. Then I will declare an output queue, and declaring a queue is actually something you can do wherever you will use a queue, because if the queue is already present in your server, then it will not be created. But you say that this queue is something that I want to use, so you declare that this queue is something I will listen to or send messages to, and the server will look if it has this queue. If not, it will create it. If it has it, it will just use the current queue with that name. And then I print out that I'm waiting for a message. I will have a consumer here that has a default consumer implementation, and this will handle some kind of delivery. And in this handle delivery, I will get a customer tag, I will get an envelope, properties, and some sort of body. And I'm not really interested in the customer tag or the envelope or properties. I'm more concerned with the body, and in this case, when I have my receiver, I will just fetch this message as a UTF-8 and then print it out. So I would say that something came on this output queue. And after that, I do this channel basic ACK and get the envelope delivery tag, so I know what the tag of that specific delivery I got is. So I will acknowledge that I actually got that tag. And the last part here is that I set up a basic consume for this consumer on this output queue. And this false here is that I actually say that I don't want it to automatically acknowledge the message, because I do my own acknowledging in the consumer. And I have tried with automatically acknowledging the message, and in this receiver, if I do that, the receiver will terminate after the first message for some reason. So if I do my own acknowledgement every time, it will be running. And if you have if you use this consumer and then stop listening and still run this program, you should actually close the channel and close the connection. But I let the program just die, and then my connections are reset, but there are functions to close them. So if you have a long running process where you are using them sometimes and then turn them off, then close the connection, close the channel. So this is my reader. So this will read from the output queue, and then I need something that sends something. So this is my little sender app. I have this connect function again. It's the same. It will get a channel. I will declare an input queue. So this is another queue I call input. And I will create some message here. In this case, I have something times something times something, but I can actually say, let's say 1 plus 2 plus 3 plus 4 plus 5, for instance. So I have a few numbers that I want to add together, and then I do a basic publish on this input queue name with my message. So this is the message over here, and then I print that this message was sent. And then down here we see an example of closing the channel and the connection, but I will remove this because I don't have these variables close as hand, because I actually moved them to a function pretty recently. So this is the sender. It's not much to say here, quite easy. So now we have something that sends to an input queue and something that listens to an output queue. So now we need the things in the middle that actually does the work. And this is my Docker service. So this is something that I will deploy to Docker in order to do this work. And it will declare both the input queue and the output queue, because I will handle both. And in my consumer here, we have the same as before. We have some handler. It will take a body and print that it received this. And then I have some result that I set to failed calculation. So if my calculations fail, I will actually send to the receiver that my calculations failed. And then I have some kind of calculations that get the result, and I will publish that result on the output queue. So I get something on the input queue and I push it to the output queue when I get the result, and I do a basic acknowledgement. So it's the same as the receiver, but I have both a receiving end and a publishing end. And then we have my consumer down here, so for the input queue. So we can close the main function. So let's look at the calculate function. In this calculate function, I will take a string expression that I had, and then I will calculate some expression. So I send the expression with something that I will look for. In this time I will look for plus. So I will do a lot of plus operators, and then I send a lambda that actually tells it how to do this operation. And this little example only handles that you send it a bunch of the same kind of operations. So I can do 1 + 2 + 3, or 1 - 2 - 3, or 1 × 2 × 3, or and so on. I can't do a mix of them because this is a very simple and just a basic example. So I will do one of these, calculate expression, and if we go into the calculate expression, it will look if the expression has any of these operators. So if it's a series of pluses, I will do it will be a plus here, and it will contain a plus. Then I will actually split on pluses, and pattern quote here is important, because if you don't do that, a plus in a split function which takes a regexp, a plus has a specific meaning in a regexp. It means that you have more than one of something, so one or more of something. So that therefore I use this quote function to actually say that I just want a specific plus. And then I create a little stream of my array here, and I will take have a result integer that I will give back from my calculation expression. And in my number stream, I will map everything to integers first off. I will skip the first one, because if I do a reduce, I need initial value. And if you do an initial value of 0 and have times, for instance, then everything will be 0, because 0 times something is always 0. I learned that the hard way while debugging. So I will take the first number in my series and have it as the first value in my reduce function. I will skip the first value and then do my operation, binary operator. So this is the lambda that I send into this function, and then I will return the result here. So I do an integer to string result, because I send strings back in my message, so that will be the easy way to do this. So let's look at it in action. So we go back here. We will start by opening up my receiver end. So I do my Maven package. So this will package up my receiver. And we actually had some failures here. I guess that the newly implemented connect function needs some throws exception. So always do live coding and recode things. It's important. There we go. Let's go back and try to build again. Hopefully this will build this time. Yeah. So now I have built my receiver end, and it does a simple test. And if I run this Rabbit receiver snapshot jar with dependencies, it will end and wait for a message. So in this case, it waits for a message until you press Ctrl+C. So let's go into the Docker service here. And here we do docker build-t. And this Docker file, I explained how to build a Docker file and how to set up this specific Docker service in another video, and I will link to it up there. So if you see the little I there, you can follow that link to that video if you want to see how you put a Java Maven application and do a Docker build of it and create a Docker file for it. So watch that video. So I will build my image latest, so that's the version of that, and I need to put a dot after it or else it will not look in the current directory. So this will download a lot of Maven tooling, and if I hadn't done this before, it will also download and prepare the specific image. But because I have built this before, some of the things will be saved in the image and other things need to be downloaded depending on what kind of changes I have done in my Docker image. I don't really know why every time I do a code change it actually has to get all the Maven dependencies for the build process again, but there is probably a good reason for that. So we do docker run it for I specified this in the video as well, but it's OpenATTY and interactive, and I will run my image. So this is now waiting for a message as well. So I have a Docker service waiting for a message that will do some calculation and send it over to my receiver. So now I only have my sender left. So I will build my sender. Everything here is built as an assembly. Everything is available on GitHub if you want to look at the code and how to set up these. You could actually build your sender and receiver as the same program, but I haven't done it here because this is a simplified example. So after built the sender, I will run java jar target, and then we have the Rabbit sender, and it will send 1 + 2 + 3 + 4 + 5. It goes over to the Docker image. We have Docker service here, and it will send 15 because that's the result, and this will receive 15 down here. So let's close this sender again and go back to the sender. So I will just show you something else here. We can do 100 divided by 10. No, we do 100 divided by 4. So we'll get 25, just to show that it actually does the calculations. We build it again. We can have the other windows up as well. And if I run this, we see that it sends 100 times 4. It will go over to the Docker service. It will send 25, and the receiver will get 25. So today I talked about how to create a RabbitMQ chain that you actually send in something on one queue. Docker service will pick up workloads from that queue, does some calculation and send the result out on another queue, and we have a receiver that will pick up that information. I hope that you learned something from this video and that you can use RabbitMQ or any other queuing software in your work as a tool. This RabbitMQ and this specific example uses a protocol called AMQ P, I think. So it's a standardized protocol, so you could use other services that has the same implementation or uses the same protocol. I hope you found this video interesting. Please share it with your colleagues and friends. Subscribe if you haven't done that yet, and I really hope to see you in the next video.